Hello students. So this problem is a very important problem that we are going to solve today. So make sure that you pause the video and solve. So they have given that an object of uniform density rolls up a curved path with initial velocity v0 as shown in the figure. If the maximum height attained by the object is 7 v0 square by 10 g, where g is the acceleration due to gravity, the object is means what is the nature of the object, whether it is a solid sphere, solid cylinder, ring, disc, that you have to find out. Okay, so first of all notice that it is rolling. Okay, so it is rolling and on a curved path. Okay, so the very important concept that you have to know here is to solve this question is this. Let's say in rolling always we know that this point which is in contact with the ground is at rest. Okay, so rolling means simply that this point is not sliding on the ground. So if it is sliding, that is not rolling. So there are two type of rolling, like uniform rolling in which there is no acceleration. So this point will have no tendency to slide in forward direction or backward direction because it is at rest, right? This is v and this is r omega, and v equal to r omega. This is the condition of rolling, right? So there is no friction acting on that point from the ground, so work done by the friction is anyway zero. In accelerated rolling, some friction can act, but which is less than the limiting friction. Okay, so because there is no sliding, again the friction will be less than the mu into n. So there can be some acceleration and some angular acceleration, but v equal to r omega is anyway valid for rolling. A equal to r alpha has to be valid because this point has to be at rest. Okay, so if this point is at rest, even if the friction is acting in this direction, then also the work done by the friction will be zero because the point of contact or the point of application of friction is not moving. Okay, so in rolling you should always remember that work done by the friction is always zero if a body is rolling. Okay, up the inclined plane, down the inclined plane, doesn't matter. Okay, so this concept is used here to solve this problem. If I know that this body is rolling, that means I know, and it is accelerated rolling because the v naught is decreasing, omega is decreasing, then only this body will stop here somewhere. So the friction will act, but the friction will not do any work. So I can use energy conservation, right? So it is, the friction is not dissipating any kind of energy. So kinetic energy here will be equal to, or mechanical energy here will be equal to mechanical energy here, right? So you know that here kinetic energy is only present. There is no potential energy. And here only potential energy is present. There is no kinetic energy because body stops completely, right? So just write energy conservation and you will get the answer. So I can write energy conservation. So initially this has kinetic energy. So it is moving with v naught speed. Let's say it is rotating with omega naught initially. So we know that v naught equal to r omega naught for rolling, right? So it has to so total kinetic energy can be written as half mv square plus half I omega square, right? For rotating body, right? For rotating and translating body, we have to write rotational plus translation kinetic energy. So kinetic energy initially is half m v naught square plus half I omega naught square. Okay, and potential is zero. And finally, there is only potential energy. Okay, so finally kinetic energy is zero. Here potential energy is zero, and here only kinetic energy is zero, potential energy is present, that is mgh, where mg and h is given as 7 v naught square upon 10 g. Okay, so this is 7 m v naught square by 10. So now just equate the energy because work done by the friction is zero. So I will equate this. So energy conservation we have to do. Now you just simplify and find out that, try to find out the value of I, because if I know moment of inertia, I can know the nature of the body, right? So this will be 5, this will be m v naught square upon 5. Okay, so if I find the value of I from here, so I have omega also in the equation, right? So omega can be substituted as v naught by r square. So I will substitute omega here. So half I v naught by r whole square, that will be m v naught square upon 5. So if I just cancel v naught square and find out the value of I, it will be 2 by 5 m r square. Okay, and this is a moment of inertia of solid sphere. You should know that. Okay. Right. So by knowing the moment of inertia, we can know the nature of the body. So correct answer for this is solid sphere. Okay. So in the option it will be given like ring, solid sphere, cylinder. So you have to take solid sphere. Okay. So remember this point, and this concept is very important, that friction will not do any work. Okay. Thank you.